So example, use the, we're going to go with trapezoidal rule. To approximate the integral from 1 to 2, 1 over x dx with n equals 5. So you're doing 5 subintervals. Okay. So the first thing I need to do with all of Riemann sums problems, you always find delta x first, the width of your each subinterval. Okay. So to do that, you're going to take b, which was 2. Why did that do that? You're going to take b, which is 2, and subtract a, which is 1, and divide by n, which is 5. Okay, 1/5 or 0.2. That's your delta x, the width of each one of your subintervals. Okay. So now we want to use the trapezoidal rule. So there's this nice formula here for how we find it. I want to find T5. Okay. So T5, it's going to be delta x over 2, right? So delta x was 0.2 divided by 2. And then it's f of x 0 plus 2 f of x1 plus 2 f of x2 plus 2 f of x3 plus 2 f of x4 plus the last one is x5 because n was 5. Okay. Oh, come on, dude. Okay. So I can simplify. This is 0.1. So x0 was the start of my interval, which was 1, so f of 1. To get x1, I just add delta x to that, so that's 0.2, so it'll be 2 f of 1.2 plus 2. You add another delta x to that, so it'll be 1.4 plus 2. What comes next? 1.6 f of 1.8 and then f of 2. I've reached the end of my interval. Okay, so the only ones without a coefficient of 2 should be your start point of your interval and the end point of your interval. Okay, so, and this is where we use our function now. Our function that we were integrating was 1 over x. So I plug these into that function, 2 over 1.4, 2 over 1.6, 2 over 1.8, plus 1 over 2. You add this all up and use a calculator to multiply, and you're going to approximately have 0.695635. Okay. Again, it's approximating the original integral we wanted to compute, the definite integral from 1 to 2 of 1 over x.